so we don't get YouTube attacked. In the Standard Model, the bare masses of elementary particles are negative and infinite. I'm going to read that one more time.
What if I told you that there's a
In the Standard Model, the bare masses of elementary particles are negative
a planet
and
that could
infinite.
potentially sustain life as we
How
know
do you
it.
address?
It's called Kepler
How do you
62F,
undress
and it's one
elementary
of the most
particles?
exciting
Is there a
discoveries in our search for
non-standard
extraterrestrial
model
life.
that may help?
Kepler
The model that he gets
62F
into is
is
something
one
called
such planet,
ADM
located
model.
in the habitable zone of its star,
So
where the
ADM model
temperature is
and
just right for
quantum
liquid water to
gravity.
exist.
Ashtekar.
But Kepler 62F
Ashtekar
is
out of
not like
everybody.
Earth in
The
many
moment
ways.
he referenced
It's
Ashtekar,
much
that was
larger,
Ashtekar's
with a
paper. You
gravity
can't really
that's
see it
twice as
right there.
strong as ours.
Do you know
It
where I
also
remember the name
orbits a
Ashtekar
smaller
from?
and cooler star,
Salvatore
which means that it may be
Pais's
a bit
interview.
colder than
So
Earth.
check out either
However, there's still a
interview
chance
1,
that
2, or
Kepler
3 with Salvatore
62F
Pais. I
could
don't
have
remember
an
which one, but he
atmosphere that
mentions
could trap enough
Ashtekar
heat
as
to
well.
make it habitable. And if that's
So
the case, it
we're
could
clearly
potentially
on the right
harbor
track
life.
here.
So,
Because
what do you
now
think?
it's Woodward
Could Kepler
describing wormholes
62F be
using
the next Earth?
Ashtekar's paper.
Only time
And
and
they use this
continued research will
ADM
tell.
model, and it does a bunch of math to basically show that it works. It says the ADM model kind of works, but it has some drawbacks. Oh wait, hold on. Let me think if this. I want to hear him say the last part here. Let me see. Where does he say this?
What we know is that the bare mass should be negative, okay? Or at least if you take the Standard Model seriously, it should be negative. The question is, what happens if you put in a negative bare mass model? Okay, gravitation only enters as a local self-energy in the ADM model. That is to say, no account is taken of coupling to the distant matter in the universe. Now, for reasons other than anything having to do with this, back at the time that I was fiddling around with this, it had already occurred to me that you needed to take Mach's principle seriously if you were going to get very far in advanced propulsion. Okay. There's an interesting thing about the ADM mass, however. It differs from the electron mass by almost exactly the square of the speed of light. It's to within 10%, which tells you something. Well, it may be just a coincidence and maybe a red herring, but there may be something there.
The ADM mass differs from the electron mass by almost exactly a factor of c squared. Now that's pretty weird. What he's implying here is that this theory may have some weight because there seems to be some connection to the speed of light. And then he says,
if you take Mach's principle seriously, what you discover is that the value of the total scalar gravitational potential is c squared, which suggests that maybe this has something to do with the ADM mass. Okay.
So now we're connecting this idea, and what he was saying is we need a model that connects gravity to electromagnetism. That's why he was looking at Ashtekar. He says, we need a model that connects gravity to electromagnetism. Well, guess what aneutronic reactions are doing, Chad? In an aneutronic reaction, the energy goes as a gravitational potential. A gravitational potential. So when the orbs are converging on the plane, but all we see is this little flash of light, barely looks like anything, looks like flipping on a light switch. That's because most of the energy in the aneutronic reaction is going into the gravitational potential, not going into the actual interaction that's happening there locally. That gravitational potential is the ripple that we see when the plane zips out.
Okay. And that if you take into consideration Mach's principle, you might be able to get back a realistic value for the electron mass.
Okay, so now what I'm trying to figure out is he's about to show this equation that made no sense to me before, and I'm going to try to figure it out right here in real time with you guys.
Okay. The bare mass should be negative, as I said. And what does all of this lead to? Well, if you're interested in finding out the details, I'll be happy to either point you to papers that I've already published, or if you like, I'll be happy to send you Mach's principle be correct. That is to say that when the gravitational mass of an object is negative, its inertial mass has to be negative too. Okay. This is, by the way, a mistake. It's made by actually some rather surprising folks. Okay. When you drop a negative bare mass object, when you drop a negative mass object,
so then here, this is the fun part. If you drop a negative mass object, normie physicists think that it's going to go up into the sky. It's going to repel. A negative mass object will fall to the ground the same way that a positive mass object does. Negative mass doesn't quite work the way that people think in their heads. I mean, it does, but it also doesn't when you actually work through the physics itself. And that's what he's saying right here. So let's skip ahead a little bit.
Right, here we go. Okay. This is the total gravitational potential due to the universe, has a value of c squared up to some numerical factor of order unity. This is the potential due to the cloud of electrically charged dust. It has negative bare mass, so this is a negative potential. This is a positive potential. When you add those things together, they're
This is why, because he's probably like pointing at something, but we just can't see it in the video.
both equal to about c squared. What you end up with is this thing dominating the denominator, and that gives you back the electron mass. Okay, up to factors of order unity to within 10% if you fetch all those order unity numbers the right way. Okay, if you could figure out how to suppress this would no longer be canceled in effect by an equal and opposite potential, and what you would end up with is this thing being of order unity, and you would end up with the ADM mass being exposed there.
So what he's saying here, and I only know this because I skipped ahead and cheated a little bit, is this theta? I'm not good at my Greek symbols. The one with the circle with the line through it that has the U next to it? That one. He's saying if you can manipulate that, you can change this equation, and therefore you can change you can change mass. You can actually flip mass around here. So now I actually understand what he's saying here. Phi, okay, it's phi. Thank you for my Greek. Look at the Greek people in the chat. Look at this. Some of y'all been in frats. Phi U. He's saying if you take phi U and manipulate it, you can flip the mass of the object around. You can turn it negative. This opens the door to producing negative energy from positive energy. That's what this opens the door for.
You work out the algebra for arithmetic for this. What you discover is that if you have a sphere 30 meters in diameter, about a meter thick of normal stuff, and you figure out how to suppress this thing here, this thing turns it into a Jupiter mass of negative rest mass matter.
If you figure out how to suppress the phi U, you can turn whatever you need into a Jupiter-sized amount of negative energy. So what he's saying there is you can turn, by suppressing the phi U, you can actually create negative energy. Because negative energy is just the inversion of positive energy. It's just about inversion. It's about duality, positive and minus, just like electric charge, just like a dipole. It's all about positive and minus electric charges. It always has been.
Okay, so in principle, if there's anything to this, and I emphasize if there's anything to this, in principle, you should be able to make Jupiter masses of negative rest mass matter to produce wormholes and warp drives and all the rest of that, if this is right. How do you do it? Well, by making phi sub u small or zero. Can it be done?
No, phi or is it phi? Make phi sub mu 0. So how do we do that? Okay, now we're in it, Chad. You guys now, hopefully everyone's paying attention now. Okay, so now we got to make phi sub u 0.
With low energy electromagnetic fields. How? That's where Mach's principle comes in. Okay. That, by the way, is Ernst Mach in his study, I believe it was around 1888 or thereabouts, in Vienna. What is Mach's principle? If you push on something, it pushes back. Why? Well, people used to argue about this, but if you look at the physics of it, you can say the gravitational action is stuff out there. Okay. Now, as you've heard, there are many different versions of Mach's principle. Indeed.
Why? I already know why. Because when we push on something, we're going to get a pushback. So if we push on the 0 point energy, we're going to get a pushback as well. Just like plucking a guitar string. You plug the guitar string and you're going to get a reaction. So what are we doing? We're plucking our guitar string. On what? On space-time. On the 0 point energy. We're plucking the guitar string on it. And then we're going to get our reaction. Zapped right out of space-time. That's what's happening with the plane.
Subtlety of the distinctions in some cases becomes almost illusory and all that. And people used to fight about this quite vehemently at times. Okay. But relativity in the skies. In a few lines shown in a vector theory of gravitation, which is a with this. Okay. But this guy here, in his doctoral work, Paul Dirac back in the early 1950s, that's Dennis Sciama, who died about 5 years ago. Okay. In a few lines shown in a vector theory of gravitation, which is of course only approximation to general relativity, but nonetheless, at the time Sciama thought it wasn't general relativity. It's turned out that it is general relativity in the skies. Okay. It turns out that if you take the gravito-electric field to be the analog of the electric field in electrodynamics, and then you ask what A is, the vector part of the form potential for the gravitational field, A turns out to be the integral of matter currents over all space and all that. Sciama used a neat trick here so that you don't get involved in lengthy, tedious calculations involving lots of algebra. He said, hey, look, if you look at an object and it's being accelerated, it looks to that object as if the universe is rigidly being accelerated in the opposite direction. Okay, so you can take V out of the integral here, and all you have to do is integrate over the matter density.
So he's saying now that, look, if you accelerate something this direction, it looks from the other perspective like everything's being pulled away from it. So what he's saying is you can treat everything as being interconnected. You can treat everything as being interconnected all the time. That is a huge revelation because we see everything as being separated. But if we see everything as being interconnected, aka entanglement, then this opens the door to an object being in one location or a different location. Because at the end of the day, you're just pulling on the fabric. You're creating one of those bridges that I was talking about before, like this. Bridge. By the way, this is the other thing I forgot, is that space-time is flat. This has been proven. You're going to go, wait, how can space-time be flat? We're living in a three-dimensional reality. I don't really know what to tell you. It's flat. Guaranteed it's flat. It's flat just like this is how we're creating our wormhole. We only see the flat surface. This is how they're creating a wormhole. They're stitching together 2 points through an extra dimension.